once glory.
Oh, gosh.
Okay, tonight we are going to discuss the circulatory system. And we're going to start by discussing the anatomy of the circulatory system. The anatomy of the circulatory system is actually pretty easy because there's just a couple of things to it, all right? You have a heart, you have arteries, you have arterioles, you have capillaries, you have venules, and you have veins. Obviously, this is a super simplified version of the anatomy of the circulatory system. But if you think about the circulatory system in terms of a well pump or a water pump of some type, what part of the circulatory system is the pump itself? The heart. Okay? So we have the heart here in the middle. And the heart is about the size of your fist. And the heart, if you look at your fist, it's about the size of your fist for everyone. And it sits inside your chest wall at kind of an angle, like that. Okay? So the top of the heart is kind of pointed toward your right shoulder, and the bottom of the heart, what's the bottom of the heart called? What's the tip of any structure? The tip of any structure. So we have two of them at the top of our lungs. We have one of them at the bottom of our heart. It's called the apex. So the apex of our heart is kind of tilted into our left lung. Okay? So we have our heart, which is our pump. And then we have our container. What is our container?
I don't know if it...
Pardon?
Are you talking about the quadrants of the heart?
Nope. The heart is the pump, okay? And it pumps...
So it'd be the arteries.
Yeah, it's all of these venules. All of these venules are all of these vessels. The vessels are the pump. Excuse me, I said that wrong. The vessels are the container. So all of these vessels are the container. And it goes out to the lungs, and it goes right out to the lungs, and then it goes out to the body. Looks like a big butterfly, kind of, right? So our deoxygenated blood comes in through our inferior and superior vena cava, and it gets dumped into our right atria. So if we're talking about our pump system still, we have the pump that's the heart, we have the container, which is our vessels, and what is the fluid that's contained within this pump system? Blood. Blood. Blood and everything that it's made of. Okay? So, our pump is actually a fairly simple pump. Very ingenious, but fairly simple. So, we're going to take a look at the heart real fast. Our heart, I better draw with black. Our heart, remember I told you that it's kind of tilted at an angle, and we have an apex down here? Okay, so our heart is divided into 4 chambers. Fair? And we have deoxygenated blood that returns from our body. And that deoxygenated blood comes into our right atria. So this little one right here is our right atria. Remember that when we're talking about anything, it's from the position, from anatomic position. Okay? So if we're talking about the right atria, it's our patient's right atria, not ours when we're looking at them. This little one right here is our left atria, our left ventricle, and our right ventricle. Okay? Now, deoxygenated blood from the body comes into the right atria. And I'm going to make it blue because it's deoxygenated. Okay, so it comes into the right atria and it fills up the right atria. as it fills the right atria, the valve between the right atria and the right ventricle opens. What is that valve called?
Bicuspid? Or is it
Tri, it should be the tricuspid. Try before you buy.
Okay.
I'm trying to find the right map, sorry. The right map, haha.
That's what I was looking at. So when you say that as it comes in, it's going to go through a 3 valve and out through a 2. Is that right?
This is where your bicuspid or your mitral valve is at. It's in the left, from the left atrium to the left ventricle.
Okay.
So we're going to go through the tricuspid valve right here into the right ventricle. And we still, at this point, have deoxygenated blood. Okay? And from our right ventricle, we're going to leave and go out to our lungs. And this is a pretty unique feature of the pulmonary circulatory system. So our circulatory system is divided into 2 parts. We have a pulmonary circulatory system, and we have the other one. Pulmonary is the one that goes to the lungs.
Right pulmonary artery blood to right lung.
Right.
Left.
So our pulmonary circulatory system is what takes it to, I don't remember what the other phrase is, and I can't get on my, systemic. It is systemic. Okay. So the pulmonary circulatory system, or pulmonary circulation, takes deoxygenated blood from the heart and puts it into the lungs. And then oxygenated blood returns to the heart. Okay? So deoxygenated blood leaves our right ventricle through the pulmonary valve. Okay? So we have another valve right in here, and this is called the pulmonary valve. This one is the tricuspid. This one is the pulmonary. Okay? Makes sense so far? Okay, we have deoxygenated blood that leaves the heart out the right ventricle and it goes to the lungs. Okay? And when it comes back from the lungs, what happens in the lungs?
Oxygenated.
It gets oxygenated. How does it get oxygenated?
Through
Through the alveoli. What happens in the alveoli?
It picks up oxygen and lets go of carbon dioxide.
And what's that process called?
Diffusion.
Diffusion, yeah. So we're going to drop off carbon dioxide here. We're going to pick up oxygen, and then it's going to return our blood. This little stream here is our blood. Now it's oxygenated, that's why it's red. It's going to return to our left atria. Okay? It's going to come into our left atria, and it's going to fill the left atria. Then when the left atria contracts, it's going to go through the bicuspid, which is also called the mitral valve. And it's then going to fill the left ventricle. And when the left ventricle pushes it out, where's the left ventricle going to send that?
To the body.
To the body. And what's going to happen in the body's tissues? Your body tissues are going to absorb the oxygen from the blood. Through what process?
That's perfusion.
Perfusion is the result. Okay. Diffusion is still the process. Okay. All right. So, and it's going to go through, it's going to leave the left ventricle through the aortic valve. Okay. When you are looking at this beautiful heart, and all of this really is a beautiful heart. I know I've got mad skills, but when you're looking at this beautiful heart, we're going to draw a little body over here too, because that's what needs to be over here. does the heart work? What makes the heart work?
Electrical pulses.
Electrical pulses from what?
Your brain.
The brain sends the electrical pulses?
It was a stab in the dark.
It was a stab in the dark. All right, fair enough. So heart muscle actually has a really, really cool feature that only exists in cardiac muscle. Anybody of the two of you, have any idea what that feature is?
Nope.
Pardon?
No.
No? Mariah? Oh, but it's such a cool feature. It's called automaticity. Automaticity. What is automaticity? Well, I guess if you didn't know what it was, you probably don't know what it is either, right?
That's true.
Okay, automaticity is the ability for the cardiac cells to operate independently of an outside stimulus. So cardiac cells, if you were to look at a pair of cardiac cells under a microscope and they were far enough away that they couldn't see each other or feel each other, your cardiac cells would continue to pump independently of each other. We're talking about individual cells under a microscope. And as those cells get closer and closer and closer together, they start to sync more until they're connected and they pump together. Super, super cool. What does that mean the heart can do?
Create its own electrical pulse.
It can create its own electrical impulses. So, pardon?
Is that why you can get like the heart beating out of rhythm?
Yeah.
Okay.
That's what causes atrial fibrillation or ventricular fibrillation. There's no more organized rhythm, so the muscles are trying to do it on their own. So, when we talk about what causes the heart to beat, we have this up here in the top of our right atria. We have this node. What is this node? What is a node first?
That's where the electrical pulses are started, right?
That's where the electrical impulses are started. The electrical impulses that guide our contraction of our heart. Okay? So up here, this is called the Sinoatrial Node. Okay? This node is responsible for the contraction of the arteries, and it begins the contraction of the ventricles. So that is our SA node. Okay? Our SA node sends an electrical pulse out through our atria and causes our atria to contract. When our atria contract, it pushes this blood that we have gathered up in here, pushes the blood down into our ventricles. Now, some of the blood is going to kind of flow through anyway because we have gravity, right? So some of the blood is going to flow through anyway, which is okay, but not enough blood, which is why our atria need to contract as well. Once that electrical impulse is released from the SA node, it is sent through the atria and then it's gathered right here in the middle of the septum. Okay, the septum is the middle wall that's in the heart. So this wall right here is the septum. And those electrical impulses that the SA node sent out through our atria, they're gathered and collected right here in this node. You know what this node's called? And here's another question. Why would the electrical impulses need to be collected there?
So it doesn't have to create more energy? It just gathers the energy already sent?
It gathers the energy that's already sent. What happens if we didn't have something to gather that energy? What would happen to these electrical impulses that were sent from the SA node?
They would carry on and cause the ventricles to pulse probably out of rhythm.
They would cause the ventricles to pulse out of rhythm. Why?
Because if you had the two nodes but they weren't connected in that way, they basically work independently of each other.
They could work independently. What happens if our atrioventricular node, that's this node right here, our AV node, what happens if our atrioventricular node isn't working at all? What if it's not doing its job and it's not collecting that signal from the SA node?
Your heart's not gonna, only the top's gonna be contracted. contracting.
The top's going to be contracting. If we're not collecting the signal, we're going to get some of our electricity to travel down into the ventricles. But what direction do the ventricles need to contract in order to push blood back out?
Bottom to top.
They need to contract from bottom to top. So the AV node's job is to gather up all of these electrical impulses and send them down the septum wall. This gathering of tissues right here is called the bundle of His. Okay, that gathering of tissues is called the bundle of His. So the SA node fires, it sends out an electrical impulse. The AV node, that's the AV node. The AV node gathers up that electrical impulse, whatever's left after it's gone through the atria, sends it down the bundle of His to the bottom of the ventricles, where it is then sent out through the Purkinje fibers. And the electrical signal coming through the Purkinje fibers causes the ventricles to contract from the bottom up, thereby pushing blood out through these valves that are up top. Pretty cool.
That is awesome.
I mean, it's a fairly simple design, but it works pretty well. Now, what happens if something goes wrong in here? We already talked about one of them. What happens if your AV node shuts down?
You're not gonna, basically not getting blood to your body and to your lungs, which would get oxygenated, sent back to your body, so you die.
You could die. If it's caught fast enough, what do you think could happen?
Go into like a seizure, maybe, I don't know.
Okay. What is the purpose of the heart circulating all this blood?
To oxygenate everything.
To oxygenate
your
everything.
cells,
Yeah, we need to make sure we get oxygen to everything, right? It needs to get to our brain, it needs to get to our gut, it needs to get to our toes. Or if we don't get that oxygen there and we can't remove waste products, those things are going to die, right? Okay, so if we're talking about the heart and how the heart works, what happens in fibrillation?
Well, isn't defibrillation like what an AED does?
Defibrillation is what an AED does. So what is fibrillation?
The opposite of that, taking away the electricity instead of putting it in the heart.
I want to look up a picture of a normal sinus rhythm because I have a good idea what they look like, but I don't know positively, and I want to draw the right one. Okay, so if we're talking about a heart rate, okay, I'm just going to draw it from what I have of a memory, and it's probably going to be a little bit wrong, but here we go. We have a heart rate, it goes up like this, and then it dips down a little bit, and then it goes up. Does that look kind of familiar?
No.
Okay. Then it goes along and we do the same thing. So this is what we call a normal sinus rhythm. Okay? Our normal sinus rhythm happens when our SA node is firing appropriately and our AV node is appropriately collecting the impulse, sending it down the bundle of His and out through the Purkinje fibers. Okay? If we have bradycardia, what is bradycardia?
A slow heart rate.
Slow heart rate. So if we have bradycardia, in this space of time, we might have a single heartbeat. Okay, it looks the same, but it's just slow. What if we have tachycardia?
Yeah,
Fast
more of
heart
them.
rate.
Fast heart rate. So it's going to look the same, but you're going to see 4 of them instead of 2. Okay. Now, let's talk about what asystole looks like. What does asystole look like? Asystole means without systole, without contraction. So what does asystole look like?
A flat line.
A flat line, yeah. So we have a flat line for asystole. So this is a normal sinus rhythm. This is asystole. So what is fibrillation?
Is it where basically top one's reversed? Or no? That wouldn't be right.
No. What it is disorganized electrical activity of either the atria or the ventricle or both. And it usually happens really, really quickly. So instead of your heart beating like this, bum, 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 your heart's going like this. And it's going super, super fast. So what it shows up as on an EKG is it shows up like this. It doesn't ever go backwards, sorry. But there's no rhythm. Okay, you can't figure it out because there's no rhythm. So what is the purpose of an automated external defibrillator?
Trying to make the heart.
Stops the heart for a second so it can reset.
It stops the heart for a second, stops all electrical activity in the heart, so that hopefully our sinoatrial node can say, oh, this is what I'm supposed to do, and kick back in with a normal sinus rhythm.
That's why if they don't have any heartbeat, it doesn't work.
Right.
Because it doesn't detect
Correct. Yeah. All right.
What was the second node called again?
The atrioventricular node. Atrioventricular node. So, I didn't write it down anywhere, but I pointed at it.
Yeah, I remember you saying it.
Okay, so the SA node is the sinoatrial. And the AV node is the atrioventricular.
And that's the order, right? SA to
SA to
AA.
AV.
Yeah, and then a bundle of his per G fibers.
Yep.